Hello everyone, it's Mr. Recor again, here to teach you Unit 2, Lesson 12, using graphs to compare relationships. So, the warm-up is a number talk, using fraction multiplication and division. So, pause the video, find each product or quotient mentally. Go ahead and pause the video. Great! So now that you solved them mentally, when you see multiplication of fractions, all you do is multiply across. So that would be 2 times 1 over 3 times 2, which is 2, 6. Same thing with the next one, but I noticed that if I have a 4 on the top and bottom on a multiplication, I can cross those out. And that becomes 1/3. Because if I did the multiplication, 4 times 1 over 3 times 4, that would give me 4 over 12, which simplifies to 1/3. Okay? Now, division is a little bit different. Some people know it as keep, change, flip. I do not like to call it keep, change, flip because mathematically you're multiplying by the reciprocal. That means it changes the order. Okay? So I'm going to write 4 and multiply by the reciprocal. Reciprocal means to change the order. And we all know what 4 times 5, or if you want to, you can write a 1 on top. And then you multiply across, that would be 20 over 1 or 20. Okay? Same thing with the last one. You got 6 times 2 over 1 because we're multiplying by the reciprocal, which is 18 over 6, also known as 3. Great job. Now, when we look at these, a number talk, you should be adding a new knowledge on top of it, and then you should be seeing something. So the first one was just multiply across. But now, in the second one, it was multiply across, but there's a cool thing that we can do if I see the same number on the top and bottom. Then the third one is, wait, there's division, but it can be changed into multiplication. And then we just multiply across. And then last is that you're multiplying across, but it could be simplified into a whole number. Okay? Great job. So today we're going to have a little bit of fun. We're actually going to solve some math problems, but also we're going to use a graph. But the important information is Diego and Lynn and May went from the ticket booth to the bumper cars. How many people have been to a fair, right? You've seen bumper cars and the ticket booth. So we're going to see and use each description to complete the table representing the person's journey. So we're mapping out how they got from the ticket booth to the bumper cars. The first one, it says Diego left the ticket booth at the same time as Tyler. Now Tyler is the guy from Lesson 11, so you might need that information. Diego jogged ahead at a steady pace and reached the bumper cars in 30 seconds. Okay? Lynn left the ticket booth at the same time as Tyler, and she ran at a steady pace and arrived at the bumper cars in 20 seconds. Apparently Mai was just looking around at all the pretty lights, and she left 10 seconds later than Tyler. And then she steady jogged. Okay? Now, what does steady pace mean? If I say somebody's running at a steady pace, what does that mean? Yeah, you're going at the same time. You're running the same way, right? You're not going faster, then slower. You're keeping the same pace. So to do that, we are going to use tables. So what I want you to do, pause the video and find the COP, and then I want you to fill out these tables. Okay? Pause the video. Awesome. Great. So, when I know, or how do I find my COP? So I'm going to write out to the side, how do I find COP? If I have both the information. Well, I take y divided by x. Now in this case, what is my x and what is my y? Yeah, time is x and my distance is y. So to find Diego's COP, what am I going to do? Yeah, I'm going to take 50 divided by 30. Why am I doing 50 divided by 30? Yeah, it's the only one that has an x and y to do. Okay? So if I do that, what do I get? Well, 50 divided by 30, I can just exit out the zeros, and I get 5/3. Okay? Now, if you have gone this far, or if you haven't got this far, I want you to pause the video and now find the tables. Great. Okay. So you should have paused if you needed it. If you didn't, great. So now what am I going to do with this COP? What operation do I use with it? Yeah, multiplication. So I'm going to multiply everything by 5/3. Okay? So, what is 0 times 5/3? Yeah, 0. Okay, what is 15 times 5/3? Yep, you should have got 25. We know that 30 times 5/3 is 50. And what is 1 times 5/3? Yeah, just 5/3. Now, if I was supposed to write an equation, now this is not asking for you to write the equation. What would the equation be if I follow y equals kx? What's the equation for Diego? Yeah, y equals 5/3 x. Great job. Okay, so now let's look at Lynn. Okay, so what two pieces of information am I given with Lynn? Yeah, it took 20 seconds to reach the distance, right? So how do I find my COP? Yeah, I do 50 divided by 20. Now, once again, we could do the same thing. 5/2, also known as 2.5. Okay? But now I'm given numbers on this side. So how do I go backwards? Well, yeah, I divide. Or multiply by its what? Reciprocal. So you would multiply by 2/5. Okay? So what is 0 times 2/5? Going backwards, right? Going forwards is one way. Going backwards is multiplying by the reciprocal, just like our warm-up. So 0 times 2/5, yep, is 0. And then 25 times 2/5, yep, you should have got 10. 50 times 2/5, you should have got 20. But now I'm going forwards, so I'm going to use a regular COP. So 1 times 5/2, which is 5/2, or 2.5. Now, EOG, on the EOG, they will ask you both ways. They could either ask you this way or this way. I need you to know that these are the both, or both of them. But when you're using dividing, I want you to keep them as fractions. Okay? Now, what's my equation for this if I write it? Yeah, y equals 5/2 x. Okay? And now, the last one. Now, at time 0, what did it say Lynn did? Or May? May said she left the booth 10 seconds later. So, what happened at second 1? Well, she didn't move at all, right? What about second 2? Did she move? No. When did she start moving? Yeah, after 10 seconds. So she was just in La La Land. Now, this math that we're going to do for this table is a little bit tricky because it's something that we haven't taught yet. So I'm just going to give you this number, 25. Okay? Because you can't just take the half of it, because this 10 was happening somewhere. I think it's the half of this 10 plus the half of this 40 gives me that 25. Okay? So, now that we have your tables, what I want you to do is graph it. Now, if you have color pencils, I want you to pause your video and get your color pencils. If you don't, you can easily do this with pencil. Okay? Pause the video and tell me when you are, and unpause it when you're ready. Awesome. Okay, so now that we're trying to graph it, let's start with Diego's. So have your table handy because I'm going to read it off. I'm just not going to show it on camera. Okay, so our first point was what? 0, 0. So we're going to draw your first color at 0, 0, or the, what do we call that? The origin, right. So my next part was 15, 25. So I go right 15 for time, and then where do I go? I go up to 25 and put another dot. Okay? Then I go to the next one. What's my next one? Time 30. And I go up how much? 50. Y'all, please do not get confused on which axis we're looking at, okay? And the last one is 1 5/3. So 1 5/3 would be around 1 something. So we're going to go like 1, and we're going to go like up here. Okay? Now, if you have a ruler, we're going to need it. I don't have a ruler, so we're going to use my handy dandy pen. Now, what I want you to do is draw a straight as you can line connecting all the dots. Well, that's not as straight. Okay. And whose line was this? Diego. So we're going to label it Diego. Okay? Now, if you got stuck before we did this, I want you to pause the video and I want you to graph Lynn's and May's. Awesome. Okay, so we just did Diego, so we're going to need another color for Lynn. Where did Lynn start? Yeah, 0. So we're just going to color over it, right? At 10 seconds, where was she? Or where were they? 25. So 10, 25. Okay? And then at 20 seconds, they were at 50. Okay. And at 1, we got 2.5. So somewhere right there. Okay? Now use your handy dandy ruler. Ooh. Okay. And whose line was this? Yeah, this was Lynn. Okay, and then lastly, let's work on May. Okay, so at 10, where was she? At 10 seconds, where was she? 0. Ooh, so her point is right here. Then what's my next point? 25 goes up 25. And then what's my next step? 40. We go up to 50. Okay. And then at 1, we can't really graph that, right? Because it's also at 0. So we're going to, once again, draw another line at, make sure you cross all the points. And this was May's. Now, they also want you to have Tyler's. So go back to lesson 11. Pause the video, go back to lesson 11, and I want you to plot Tyler's. Okay? So, Tyler's, I'm going to need another color. Let's use orange. Okay? So Tyler started also at 0, 0. At 20 seconds, he was at 25. At 30, he was at 37.5, so. And then, at 40 seconds, he was at 50. Okay? So I'm going to use my handy dandy ruler. Okay. Okay, and who was the orange? That was Tyler. Okay. Now, let's answer the question. It says, which person is moving the most quickly? So I want you to pause the video, talk with your neighbor, answer this question. Which person is moving the most quickly? Okay, great. So you should have seen that based off the graph, Lynn was moving the fastest. Why? Because this line is approaching. It's really steep. You see how high that line goes? When we're talking about graphs, if it is higher, that means it is faster, or it goes faster, right? So we can see Tyler is going a lot slower because if you look at it, what was his distance at 20? At 20, it was only 25, but Lynn was already at the ticket booth, okay? So the steepness, we call this the steepness of the line, which is how it's angled. A steeper line, meaning a higher line, has a higher constant proportionality. And we can see that here. This is 2.5. What was the COP for Tyler? Yeah. So we can see that that's higher, therefore it travels more quickly. But in a graph, that means the line is more steep. So, using that information, let's go to 12.3. The meteoroid, is it Perseid 245, and asteroid X travel through the solar system. The graph shows the distance each traveled after a given point in time. This is the graph. is asteroid X traveling faster or slower than Persei 245? So I want you to pause the video and answer this question. Great. So you should have said asteroid X was traveling, yeah, faster. What tells us that? Well, it's the steepness. It is more steep, or it's higher than Persei, okay? And that's all that question was asking. And then last one, in the graph that shows the price, this is price, so price, and length, if you buy $1 of each kind of rope, which one will be longer? Okay, so let's say this is $1 right here. Which one's going to be longer? So we follow this imaginary line. And then we look down. Who would have a higher length? Talk with your neighbor. Yeah, it would be nylon. Because at $1, nylon, you get more. Okay? So today's lesson was to interpret graphs. The steepness of the line matters. Okay? And the higher it is, what is it? The faster it is, or the higher COP. Okay? Great job, guys.